Thousands of students are literally bleeding marks on the Cambridge IGCSE Physics Energy paper right now. And the worst part is, they don't even realize it. You could walk out of that exam hall feeling like an absolute champion, only to get your results back and wonder, wait, where did it all go wrong? Well, today, we are going to fix exactly that. I'm going to act as your personal examiner whisperer, revealing the specific words and strategies that pull marks from the grading scheme straight onto your paper.
Okay, let's dive into this right away. Imagine a student performs a really complex, multi-step calculation, and they do it perfectly. The numbers are crunched, the algebra is totally flawless, the calculator work is top tier. But when the examiner's red pen actually hits the paper, this answer scores an absolute zero. Nothing. Nada. So, why does a perfectly correct mathematical process result in a complete and total penalty?
Here is the painful truth. The final answer was written simply as 45.3. And look, without a unit, 45.3 means absolutely nothing in physics. Is it joules? Is it watts? Is it potatoes? The examiner literally cannot give you the benefit of the doubt. Missing your units, or even just rounding your numbers too early and you're working out, completely strips away the absolute easiest marks on the entire paper. This perfectly demonstrates why ordinary textbook revision simply isn't enough. You really have to know the rules of the game.
Now, these are the exact syllabus traps that examiners can spot from a mile away. Missing standard units like joules for energy or watts for power, that's just the start. Rounding too early causes these nasty cascade errors that completely ruin your final significant figures. Then, we have vague explanations, using everyday language instead of actual physics terminology. And don't get me started on practical questions, where we constantly see graph axis errors and students mixing up independent and dependent variables. If you do any of these, you are practically handing your marks right back to Cambridge. To completely bulletproof your exam strategy, we need a reliable system. Let me introduce you to the absolute ultimate 4-step top-band answer framework. First, you state the concept. Second, you provide the evidence or data straight from the question. Third, you apply your scientific reasoning. And finally, fourth, you package the whole thing in strict examiner wording. This right here is the blueprint for a maximum mark answer. When you follow this flow, you aren't just hoping for marks, you are magnetically pulling them to your page.
Now, I need you to pay very close attention here. In a moment, I'll show you the examiner clue that changes the answer completely. But first, you need the framework that makes that clue obvious. Because honestly, if you don't grasp the core concept first, that massive clue will slip right past you and you'll fall straight back into the traps we were just talking about.
So let's hit step 1 of our framework, the concept. For this specific topic, the absolute core concept you must state to secure those initial explanation marks is the principle of conservation of energy. Energy cannot be created or destroyed, it can only be transferred between stores. Write this down, memorize it, engrave it in your brain, and deploy it whenever a question asks you to explain an energy change in a closed system. It is literally the golden key that unlocks the rest of the question.
And this distinction right here brilliantly illustrates where so many students go off track. You have to clearly distinguish between energy stores and energy transfers. Kinetic, gravitational potential, chemical, and thermal, these are your stores. They're where energy lives. Mechanical work, heating, and radiation, these are transfers. They're how energy moves. If you write something like, energy is mechanically stored, the examiner will instantly dock a mark for vague, incorrect terminology. Just remember, stores hold, transfers move.
All right, let's move to a practical application and see how this all builds together. It's time for a pause and predict challenge. Imagine a motor lifts a 50-kilogram load by 2 meters in 5 seconds. How do we calculate the power? I want you to actively think about the equations you need to pull off here. Think about the work done, think about gravitational field strength, and think about exactly how time factors into power. Do you have your mental math ready?
Okay, the substituted value you should have reached is 196.2. Let's break down the examiner-style correction nice and clearly. First up, calculate the force, which is the weight. That is mass times gravity. So 50 kilograms multiplied by the gravitational constant of 9.81 meters per second squared gives you exactly 490.5 newtons. Next, work done is force times distance. Take that 490.5 newtons and multiply it by 2 meters. Boom. That gives you 981 joules. Finally, power is work done divided by time. Take your 981 joules, divide by the 5 seconds, and the calculator gives you 196.2. But wait. Remember our very first trap. To lock in those method marks, you absolutely must write 196.2 watts, or a capital W, and carefully verify your significant figures based on the data given in the exam.
Let's look at the examiner wording step of our framework in action. A typical, highly flawed student explanation claims, the motor uses energy to lift the box. Now that sounds totally fine in everyday conversation, right? But in Cambridge 0625, it earns 0 marks. However, a rigorous top-band answer states, chemical energy store transfers to gravitational potential energy store mechanically. Do you see the difference there? It names the exact starting store, the exact ending store, and the highly specific transfer pathway. That is how you command full marks on these papers. Let's escalate the stakes a bit. Here's a spot the error moment on a much harder evaluation example. Imagine a student is calculating the efficiency of an engine. They divide the total energy input by the useful energy output. So what is completely fundamentally wrong with this setup? This is a nasty trap that catches out even top-tier students when they are rushing under exam time pressure. Exactly. They flip the formula. Efficiency is always the useful energy output divided by the total energy input, and to make it a percentage, you multiply the whole thing by 100%. The absolute golden rule of efficiency, which actually acts as a brilliant built-in safety check during your exam, is that efficiency can never be greater than 100%. If your calculator spits out 120%, stop immediately. You have flipped the output and the input.
When we break it down visually, we can easily see exactly where that so-called lost energy goes. The total input energy always equals the useful output energy plus the wasted energy. And here's the trick. We call this wasted energy dissipated energy, which is usually transferred to the thermal store of the surroundings. Using that specific word, dissipated, in your written answers is a massive mark magnet. It shows the examiner you have the evidence and the data to back up your scientific reasoning.
Okay, we are pushing into the absolute hardest question type on the paper, evaluating a practical investigation. Here is your interactive challenge. Let's say you are looking at an experiment measuring the cooling curve of hot water in a beaker. The data is messy, and the curve isn't smooth at all. The examiner asks, suggest 2 valid improvements to this practical method. How do you answer that?
Here is the examiner's style feedback you need. To secure those practical method marks, you must be hyper-precise. Simply saying, be more careful, scores 0. They will literally laugh that off the page. Instead, you need specific, actionable variables. Say things like, use a lid to reduce heat loss through convection and evaporation. Or stir the liquid before reading the thermometer to ensure a uniform temperature. Even control the ambient room temperature. And always, always ensure your graph scale covers more than half the page to reduce uncertainty. These are the specific safety checks and variable controls required to score full marks in Paper 5 and Paper 6.
So the absolutely crucial point here is that by using the concept, data, reasoning, and wording framework, you have now mastered the traps in the energy topic. But here is the massive, unresolved problem. Applying this framework to energy is just one tiny piece of the puzzle. What about the vicious, hidden traps lurking in the other question types across different paper formats? What about the command words that trick you into explaining when you should only be describing?
Well, before we get to that, make sure to subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Mastering the entire syllabus really requires consistency, and we are right here to provide the structured, highly focused learning you need to achieve those absolute top grades.
So the big question is, are you letting simple language lose you complex marks? Mastering energy is just the beginning. Leaving now means you will walk into the exam hall completely blind to the command word traps that consistently ruin perfectly good physics knowledge. You need the full picture. It is absolutely mandatory that you click the next explainer right now, Physics 0625 Common Traps by Question Type. There are way more mark magnets waiting for you right over there to bulletproof your exam strategy. I will see you in that next explainer. Keep studying smart.